Hi everybody, welcome to the Absolute Temperature Lab where we're going to prove absolute 0 Kelvin, the lowest temperature possible. So you guys are going to have your Bunsen burner set up like this, and you'll have a butane lighter to light your Bunsen burner. We've been using those flint strikers for a really long time, but we think that the butane lighters are going to be easier for everybody to use. They have a little button right here, a little push button, and that was really super easy, way easier than a striker. And yeah, please don't play with these or waste the gas that's in them, and just set them aside. There you go. Next thing you'll have I guess a large, a medium, and a small Erlenmeyer flask, and you'll also have these rubber stoppers that have holes in the top. And there's a special rubber stopper that fits in each Erlenmeyer flask. You want to make sure that your water is boiling, and then, well, mine's not quite yet, but I'm pressed for time, so let's put that Erlenmeyer flask in, and we'll heat it once the water's boiling for at least 1 minute. It's in the water for 1 minute boiling, and that's going to heat the gases on the inside. Those gases are going to expand, and as they expand, the particles of gas are going to push out of that hole in the rubber stopper. After a minute, you might even want to wet your finger and cover that hole so that it is airtight, and remove the Erlenmeyer flask and bring it all the way over here to your ice bath. Now notice I'm using my index finger. If you use your thumb, this turn is really, really hard. So use your index finger to cover the hole, flip the Erlenmeyer flask over, and put it down into the ice bath. This is where you let go of the hole, and if your hand is freezing in this freezing ice cold water, which when you guys do it, there's going to be ice in here, then you just hold the top of the Erlenmeyer flask like that. It's okay. You're just waiting for it to cool. We think it takes about 2 minutes in here with your fingertips freezing for the gases on the inside of that flask to cool and contract. And as they contract, the pressure on the inside of the flask is going to go down. And the air pressure will push the water into the flask. The atmospheric air pressure will push the water into the flask as the gases in the flask contract as they cool. Anyways, now you know the volume of that gas at 0 Celsius or close to 0. Grab your thermometer and find the temperature of this water. Now, reversing this move is a little tricky, especially if one hand is holding a camera. You want to hold that hole in the stopper again, and you'll pull the flask out, and notice now there's been a little bit of water that got pushed into the flask by atmospheric pressure, and because the pressure on the inside of the flask decreased as the gases inside the flask cooled and contracted. All right, once it's out of there, you can take your finger off of the stopper. Back here at your desk, you want to measure the volume of the water that entered your flask, okay? So that's what this graduated cylinder is for. And you'll pour your water into the graduated cylinder, and that is the amount of water that entered the flask when the flask was immersed upside down in the ice water bath. All right, once you know that volume, and it's written on your lab sheet, that's really, really important to write that value down. You can empty out your graduated cylinder, take that Erlenmeyer flask, fill it all the way to the top now, and find the total volume of the flask. The total volume of the flask is the volume of that exact same gas. In fact, the exact same particles of gas that were in there in the ice water bath. But when the flask was at 100 degrees Celsius. So you'll have two different temperatures. You'll have a 100 degrees Celsius temperature and volume, which is the total volume, Notice I put the stopper in because there was a stopper in there before. That's your total volume at boiling. And then you need to find that volume with your graduated cylinder. If your Erlenmeyer flask volume is greater than the volume of your graduated cylinder, then you write that number down like you did in our measurement lab. Write that down to the nearest tenth of a milliliter. That's your uncertain digit. Pour it out. Pour the rest in and add those two values up. That's your total hot gas or 100 degrees Celsius volume. If you subtract the volume of the water that entered the flask in the ice water bath from the total volume of this flask, you'll have a little bit smaller volume. And that'll be the volume at 0 degrees Celsius, or the temperature that you measured the ice water bath to be with your thermometer. Then, so let's say that at 100 degrees Celsius, we found that the total volume of that Erlenmeyer flask was about here. And then we subtracted from that value the amount of water that entered in the ice water, and we got this slightly smaller value. And you remember that in the ice water, it was really close to 0 degrees Celsius. All right, well, we throw a ruler on that, and if you're measuring unknown points in between known points, that's called interpolation. But if you're measuring unknown values outside of your known data set, that's called extrapolation. And look what happens here. We get to this point on our straight line if we assume that it is a linear graph, and my measurements get me close to about 245, and that's really, really rough. Again, we're trying to prove that 273.15, or somewhere in this region, the gas volume should decrease as we lower the temperature to 0, and that's the point of the lab. When you guys are all done, you're going to have 3 really wet Erlenmeyer flasks. And you're going to grab those and go over here to the drying oven. Open it up. Put your flask on the drying oven shelf. And grab dry flasks off of this cart. And put those dry flasks back at your lab bench for the next period. It would also be really nice if you took the corks and dried them. Grab a piece of paper towel, or maybe even dab them on a sponge, and put those next to the flasks that match them in size. So next period we'll have dry flasks and dry stoppers. Pro tip, please don't put the stoppers in the oven. They'll melt. Good luck today, you guys. Thank you.